the discriminant. We've been working with the quadratic formula now, and we know that this piece here gives us the axis of symmetry, or maybe you consider this right here to give you the axis of symmetry. And we know that this whole thing here, the whole quadratic formula, when you consider both the positive and the negative, or the positive and the negative, you know this whole thing is going to give us the different x-intercepts of our quadratic. But what is the discriminant? The discriminant is quite simply this piece underneath here, the piece underneath the square root sign, underneath the radical. And what this does is this is going to tell us how many solutions the quadratic has. How many solutions, or you can also say solutions, we also say roots, we also say x-intercepts, we also say zeros, lots of names for this, but how many solutions the quadratic has. So let's take a look at a couple examples. So first thing, just like always, whenever we use the quadratic formula, we identify, first we have to have our equation in standard form. So it has to be in standard form, which it looks like here we have 3 different equations already in standard form for us, so that's nice. And then 2, we identify the A, B, and C. Identify A, B, and C. And then 3, solve or let's say calculate. Let's say calculate the discriminant. So calculate the discriminant. And what this is going to do, again, this is going to tell us how many solutions that we have. And you might be thinking like, well, what are the different possibilities of solutions that we could have? Well, one possibility could be something that maybe looks like this. So we might have a quadratic that looks like that cuts through at 2 different spots. Now, this is not exactly to scale with this equation down here, but we can see that it does cross at 2 spots. Or maybe if we've got a perfect square, maybe it's just going to cross at 1 spot. Oh, that's not going to make a quadratic for me. Maybe it's going to just cross at 1 spot for us. So it's just touching right here. So what does that leave for the last one? The last one means that there's going to be no solutions, where it's maybe floating above or sinking below. So you could have also maybe a graph that looks like this, or you could have one, if we look at the purple, where it's just touching, but it's going down. It's not quite touching, but it's going opening down. Or maybe you have, again, one of these that, sorry, no, that one's supposed to be crossing at 2 spots. So maybe you have one like that. So all of these are different variations of 2 solutions, 2 solutions, 1 solution, and no real solutions. No real solutions. And we say there's no real solutions because you can actually find these things with imaginary numbers, but we say that there's no real solutions because that's mostly what we're working with. So you could also say there's one real solution here too. So maybe if we want to be a little bit more precise, we can say that there's one real solution. And that just means real numbers, the numbers that we typically work with. We're not using imaginary numbers. So we'll say here there are 2 real solutions. Okay, so what does that look like? Let's use the discriminant for our A, B, and C here. So first, our A, B, and C. A equals 1, B equals -3, and C equals +2. So if I use this to solve for the discriminant, the b squared minus 4ac, and I say b squared, so -3 squared minus 4 times a times c. So I've got 9 minus 8 which is equal to 1. Let's look at one real solution. And then we'll come back and make a summary. Let's look at one real solution. That says we've got our A equals 1, B equals 2, C equals 1. So here, let's keep all of these the same color. That might make it a little bit easier. Okay, for our purple, we've got b squared, so 2 squared minus 4 times a times c. So we've got 4 minus 4, so we get a value of 0. And what about our red one? So we've got our a equals 1, b equals 2, c equals 4. Now, of course, all of these have a values of 1. That doesn't mean that every single a value has to be 1. Of course, you're going to have lots of different quadratics with different a values. I just chose this for simplicity's sake. So we've got b squared, 2 squared, minus 4 times a times c. So we've got 4 minus 16, which is minus 12. So what are the conclusions that we can pull from these three different answers or solutions for our discriminant? Again, the discriminant is b squared minus 4ac. So if the discriminant, if b squared minus 4ac is greater than 0, then you have two real solutions. Two real solutions. If b squared minus 4ac equals 0, then you'll have one real solution. Or we call that a repeated root. And if b squared minus 4ac is less than 0, then we have no real solutions. So it does not cross. And that hopefully makes sense, because if we think about what does a negative square root, we can't do a negative square root. So that means it's not possible to calculate this. So we're not going to have any solutions. There's not going to be a place to cross the x-axis, because we're coming up with a number that we can't calculate in the real number system. And over here, if we have one real solution, so let's say, if we have, one real solution, if this thing is 0, then we've got let's go over here. Negative b over 2a plus or minus, well, the square root of 0, it equals 0. So the square root of 0 is 0. 0 divided by anything is still going to be 0. So you just have the axis of symmetry. So the axis of symmetry is the value that is crossing or touching the x-axis right there. So we have one real solution, one place where the quadratic crosses the x-axis or touches the x-axis. And if the discriminant is greater than 0, well, then you're going to have multiple numbers. So in this case, we've got the value is 1. So we'd have negative b plus the square root of 1 divided by 2a, and negative b minus 1 divided by the square root of 1 divided by 2a. So it's going to give us two very distinct real roots. So the discriminant is just a quick way, if you're looking for solutions, maybe you're looking at a contextual situation, maybe you're just trying to figure out real quickly how you're going to graph this thing. You can pop in the discriminant real fast so you have an idea of what you are possibly looking at, along with the a value if you're going to be opening down or up, and then you can have a rough idea of what you are looking for. So again, this comes from the standard form, because we know the quadratic formula comes from the standard form. And we just need to identify, do we have no solutions, one solution, or two real solutions?